Thanks, Aaron. Appreciate it. As Aaron mentioned, I'm Alan White. I'm a practice leader for the SQL Server consulting practice at Upsearch. Just a little bit about me. I've been in IT for 40 years. And so in that time, I've seen a lot of things. I've done a lot of things. I started working with SQL Server on the Sybase platform back in 1992. And then when SQL Server 6.0 came out in 1995, we switched our applications to that. And I've been working with SQL Server for this entire almost 23 years now. My certifications are there, and for the last 8 years I've been awarded the SQL Server MVP award, which is a singular honor. I really appreciate everything that Microsoft has done for those of us in the MVP program. So that's enough about me. Let's talk about using PowerShell to maintain our baseline. Baselines are important. Baselines tell you what performance looks like under normal conditions. And by capturing that data and recording that data, you get an understanding of what things look like when they're normal. So that when somebody says, hey, your database is slow, because none of us have ever heard that before, when somebody says your database is slow, you can look at the performance counters, and you should have already an understanding of what the patterns look like, and then you can look at the changes from that pattern and see what the heck is going on. And that helps you focus your efforts on the areas that really are a problem instead of just guessing to see what the problem might be. Now, how frequently we capture that data is important. If you don't capture the data frequently enough, you'll miss critical information. If you capture it too frequently, however, you'll actually impact the performance on the server yourself just by gathering that data. And how frequently you need to capture that data really depends on your experience of what your servers can handle. I've heard anywhere from 1 minute between capturing performance counter data and 15 minutes. Now, I personally think 15 minutes is too long, and my experience has been good with 1 minute. But I've seen cases where somebody actually captures data once every second. Now, that's a lot of data. So I would start probably in the 5-minute range and then adjust based on your own personal experience. What counters do we need to follow? And you can talk to any number of experts in the area, and there will be variations in just about every one of those experts in what they tell you. So what I'm going to give you are my choices for a generic system. When I walk in the door, what do I want to look at? These are going to be my choices. First thing I want to look at is the operating system counters. I want to look at the percent processor time used. Now, the bean counters like to see every resource you have used to its maximum. But we all know that when we have processor use, percent processor time up at the 90-95% area, we have performance problems. Things are not running well when it's up there. So I'm going to keep an eye on that. I'm going to look at the available megabytes under the memory counter, because if that counter is going down, I'm likely to be paging out to disk. And when I'm paging out to disk, things are slowing down. Memory access is way faster than accessing the information from the disk. And so if I have to swap that memory out to disk because I'm running out of memory, that's a problem. So I want to keep track on that. Similarly, I want to keep track of the percent usage of the paging file. So if that number starts getting high, I'm doing excessive paging to disk, and that's bad. I look at the physical disk counters, average disk seconds per read and average disk seconds per write. There are a lot of disk counters that you can look at. These particular ones are valid whether you're on local copper, whether you're on a SAN disk, whether you're on SSD, no matter what physical disk architecture you're using, latency is latency is latency. So I'm looking at these latency numbers to see how much time it takes to get the data from the disk to my operating system. And if that is less than if it's less than 20 milliseconds, 0.02 seconds, I'm happy. If it starts getting over 1 second, I'm going to talk to the I.O. guy, to the I.O. subsystem guy, because we've got some problems. Now, one thing to remember if you're using virtual hardware, if you're using virtual machines, be it VMware or my brain just went south on the Microsoft because I use VMware pretty much across the board.
Hyper-V.
Hyper-V, thank you, Baron. One thing there is some discrepancy between the latency that your guest OS is going to see and what the physical I.O. system is delivering to the VM host. And right now, there isn't a lot of exposure to what those gaps are. I was out on the VMware campus last September, and we talked about this extensively and asked them to give us some counters on the VM host that expose some of the latencies that happen in the translation from the physical I.O. subsystem into my guest OS. That's not entirely there yet. Just be aware that that gap does occur. So another counter is the processor queue length, and if this counter starts to get high, what it's telling me is I've got an inadequate number of CPUs available. My queue length is telling me that I don't have enough CPUs to handle the worker threads that are trying to get stuff done for SQL Server. I had a client once that had their month-end process, and it was running a good 3 hours every month. And when that process ran, nobody else could get anything done. And for business reasons, they had to run it during the day. So it literally brought everybody to a crawl while the month-end process ran. So they said, can you look at that? Is there anything you can do about that? And I looked at the process. I looked at the performance counters. I saw processor queue length was high, and I said, "Hey, can you give me some more processors?" They only had 4 processors allocated to that virtual machine. So they said, "Sure." In the next maintenance cycle, they doubled it to 8 processors. And then again, a month later, we looked at the performance counters while month end was running. And everything looked a whole lot better, and month-end ran in 45 minutes. So these counters can give you an idea of what to look at when problems occur. So these are the operating system counters that I watch. And then there's the SQL Server counters. Access methods, I look at forwarded records per second. And essentially this tells me if my heaps, my tables without clustered indexes, are getting fragmented. And in SQL Server, I think it was SQL 2008, that they introduced the ability, the alter table rebuild statement is the only way to defrag a heap. So, but this forwarded records per second tells me if I'm getting fragments in my heaps. Page splits per second, you're always going to get page splits. If SQL Server says, hey, I need more space for this table, when you're inserting rows and it just tacks on pages to the end of that, it counts that as a page split. That's a good kind of page split. The bad kind of page split is when it's trying to insert a row into a page that's already full, and it has to take half that data from the page that you're trying to insert and move that to another page. That's the bad kind of page split. And the only way to tell the difference between the good kind and the bad kind is to use extended events. And Jonathan Cahias of SQL Skills has written up a blog post or two about how you determine the good versus the bad page splits. But I'm just looking to see what the count looks like on an average basis. If that count starts to get higher than normal, again, I'm looking at some fragmentation, and I want to use some index rebuilds to correct that. Buffer cache hit ratio. I want to take a look at that. It just gives me a rough idea of how effectively I'm using the buffer cache. It's almost non-usable anymore. This particular counter used to be really valid in the 32-bit SQL Server days and the SQL 2000 and earlier. But I'd still keep it around just because it's an old friend and it's friendly, and I just still like to keep an eye on it. Page life expectancy is an interesting counter that gets a lot of discussion. I don't use this to make sure that I have a high number of page life expectancy. The books online will tell you that the number should be greater than or equal to 300, or at least it used to. That number is no longer valid. And again, Jonathan Cahias did a nice blog post on his blog at SQL Skills where he recommends that this number should be under normal circumstances a value of your data cache size in gigabytes divided by 4, multiply that by 300, and that's your target number. But if you run a DBCC check DB, your page life expectancy is going to go to 0. That's known behavior. Paul Randall, who wrote DBCC check DB, has acknowledged that that is exactly what happens with that counter. So what I use page life expectancy for is to look for patterns. What's going on the server? When this number drops, that means somebody's accessing a lot of data on disk, so it has to flush out the older stuff in cache. When I see that drop during the day, I say, okay, who's doing something they probably shouldn't be doing? Where's that marketing guy that ran that report we told him he could only run on weekends, right? So that's essentially what I use page life expectancy for, and I find it valuable for that. Processes blocked, you're always going to have blocked processes. It's part of using SQL Server in a concurrent mode, right? You have more than one person using SQL Server, and inevitably you're going to block. What I look for is to see when this number gets out of line, what outside of normal number of blockages, right? So it's a baseline counter, in other words. Batch requests per second just tells me how busy my system is. I arbitrarily threw down 1,000 for being a busy system. I've got a client where if that number is 2,000 to 3,000, their system is really busy. A friend of mine who works for Microsoft told me about a case for a client of his that complained when this counter dropped from about 50,000 down to about 30,000. They were experiencing severe slowdowns, and it was evidenced by that batch request per second. It dropped to 30,000. And he researched and figured out what the problem was, and they solved the problem, and it's back up to 50,000, and they're happy. So the number that you have in your system is dependent on your workload. And so if everybody's happy and it's in the 50,000 range, that's your baseline. SQL compilations and recompilations per second I look at to give me a rough idea of how well I'm doing in maintaining my statistics. If SQL Server starts compiling and recompiling stored procedures and queries, I'm probably got a case where my data and my statistics are out of line. And if I implement a regular process to maintain my statistics, I'll keep this counter down. So I'll look at these counters to tell me when it's time to work on the statistics in my SQL Server database. So those are the counters that I look at. Let's see how we can gather those.
Hey, Alan, can I, a couple questions in there.
Absolutely.
And a little clarification, capturing the statistics from those counters for 1 minute, for how long? For a full day, for an hour?
Well, I capture them once a minute, 24 hours a day, 7 days a week.
Okay.
And by doing that, and I'll show you the code in a few minutes, but it's essentially per server, it's 1,440 data points per day. It's really not a lot of data when you think about it. If you think about the number of rows that a normal business application throws into a database, it's generally more than 1,440 rows in a given day. So,
yep, heck, even Excel can handle that.
I wouldn't try it, but yes, it could. So that's essentially what I do. You can talk with people that you trust and see what their thoughts are. Usually, people like Andy Kelly and Kevin Klein, who are people that I've looked up to from the time I started working with SQL Server. You know, they usually argue 5 to 15 minutes time frame, but I haven't run into an issue doing it once a minute, so I keep going there. All right, let's take a look at how we can gather our performance counters. One of the things I learned early on when I was doing PowerShell using SQL Server 2008, 2008 R2, and even SQL 2005 is we were in the PowerShell 1.0 days prior to the implementation of the GetCounter commandlet. But performance counter data has always been available in the .NET framework using the system.diagnostics.performanceCounter object. And so I simply instantiate a new performance counter object. I give it a category, in this case processor. I give it a counter name, %processor time, and I give it an instance. So if I have multiple processors, I want the total. I initialize the counter, and then I bring back use the next value method. Now, performance counter, the %processor time counter is an incremental counter. So it looks at what it was the first time, and then the next time you run the counter, and it essentially pulls the difference. So the very first time you run that use that counter, it's always going to return 0. But if I run it again, now it's 1.54. Now it's 2.12. I'm not putting a lot of load. This is a demo machine. There's no real workload going on. So it's not under heavy use. But if you look at perfmon, these are essentially the same numbers you're going to get from perfmon. Similarly, I can initialize a counter for available megabytes, and I can pull back that value, and 1462 is what I've got. That counter doesn't change a lot as long as I've got activity going on. So this is how I used to do things in the PowerShell 1.0 days. And the really cool thing about this method is that it is available from 1.0 on. It's always been available within PowerShell. And you don't have to load any modules to use that. But PowerShell 2.0 introduced a new commandlet called GetCounter. We specify the computer name that we want to get the counter from. We specify a counter value. And we specify a sample interval. So in this case, it's 1 second. And we can specify max samples. Keep moving things here. We can specify max samples. In this case, I'm going to just get 1. You'll see how I've implemented this into a script in a moment. To set up the counters, okay, my server name is my local server, SQL TVWS. My instance name is a named instance of SQL Server. Named instances, the counter name starts with the service name that you'll see if you look at the Windows services. So in this case, it's MSSQL $INST02. If I was using a default instance, the INAME value would be just SQL SERVER. So just for your information, but I've got this coded here, and I'll show you how I've implemented that in the script. But if I specify these counters, now here I'm building an array of the information that the counters argument is looking for. %processor time, available megabytes, paging file % usage, You notice the instance is in parentheses behind the counter type, so the category. This is how this is constructed. But once I've set those values, I can use the GetCounter commandlet to get those counters from my system. Now if I look at the contents of the the $counter variable, it's an object. It's a counter type object. If I do get member, you see it's a performance counter sample set object. And if we go back to what its contents, I only ran it once. It comes back with a timestamp value, and then it uses all of the counter specifications I put in that array and returns the values. So, and it gives me the server name, the counter name, and then the value for that, all through the whole set. So you see my buffer cache hit ratio is at 100. My page life expectancy is at 6016. Everything else is at 0. As I said, I don't have a workload going on this server, so there's not a lot to see. But all I need to do now is parse through this set of counter samples data to bring back those counters. How do I do that? With this script right here. So I've got a PowerShell script. Here's my comment-based help, so anybody running this script can see what the synopsis, the description is. I've got 5 arguments here specifying the server name. This is the box name, not the named instance. It will parse through and find the named instances for us. The interval, so normally I'm going to do an interval of 60 seconds, 1 minute. End at, so this is going to run until it reaches this date and time. In this case, it's the end of the year of this current year. My target server name, where I'm going to actually write this data when I'm done with it, and the database name, where I'm going to write the data. I'm going to use the managed computer object built within SMO to determine the instances of SQL Server running on this server. In this case, this particular box that I'm running my demonstration on, I actually have a couple instances of SQL Server running. Instance 1 and instance 2. So if I go back to my script, I can get the information on those instances by going into the server instances object within my managed computer object and pulling out the name of each instance. And now in this case, I'm creating an array with the server name, the box name, and the instance name. And that is going to go in a variable called $inst. Then within the script, I'm going to say, well, I'm not yet at my ending date that I specified in the parameters. Then I'm going to pipe the instance variable to a for each object commandlet, and I'm going to look at the instance name. And if the instance name, the service name, is MS SQL Server, that's a default instance. And I'm going to specify the service name as that name. Otherwise, the instance name is the named part of the named instance. So it'll be like INST01 or INST02. So this construct puts together that service name properly for me. I'm going to check, using getService, I'm going to check the status of that, and if it is running, I'm going to build an instance name for my counters. Now, if I'm using the default instance, the counter name is SQL Server. Otherwise, the counter name starts with the service name. So this is how I built this iname variable there. Then I use that information here to build my SQL Server counters in my counters array. Once I've done that, I use the GetCounter commandlet, just like I did in the demo before, and I pull out the timestamp value and assign that to my $DT variable. So I have the time that it actually gathered those counters from the server. And then for each of the values in the counter samples collection, remember here, I've got a collection of values back from counter samples. So I look for the actual counter name, and I take the cooked value property from that counter and assign it to a PowerShell variable. Available megabytes into my available megabytes variable. On through, percent usage goes into page file percent usage. Again, all the way through all of the counters that I specified in my counters array, pulling the cooked values. And then I've got a stored procedure that says insert server stats. Server ID is actually an identity value that inserting the row in the server stats table returns an identity, so I can link the operating system counter values together with the SQL Server instance values. So in my query, I use declare my server ID and that integer, and so it returns back the value it just inserted, the identity value. I give it my box name, the performance date, and the operating system counters. There's a semicolon because the last thing I do in my query is assign the output variable. I say select that as server ID. I use that query in my invoke SQL CMD commandlet against my destination server and destination database. There's a variable with the query. It takes the results and puts the results in that $res, and the server ID property is there, so I now have the identity value for the server-side counters that I just inserted. I add that to the instance counters, and then add the server name, the instance name, and on all of my SQL Server counters in the instance stats insertion. Query looks very much the same. It's just a different set of counters. I cycle through each of the instances that are on that server, and then when I'm done with all the instances, I sleep for the number of seconds I've specified in that interval counter that I put in the script arguments. And then, of course, I've got my error handling because PowerShell runs under .NET. .NET uses a hierarchical structure for the errors. The errors are very, very rarely at the top level, the ones that actually tell you what the problem is. They're very rarely at the top level. They're usually buried at the innermost error. So this actually writes to the output all the way down to the innermost error to tell you what problem occurred. So if this script actually gets to that expiration date time, it will end out and write out to the output that script is completed. It's very rarely that I'll set that date to a date and time that it can reach. So I actually put that code in there initially for demo purposes, and I've just left it there. So this is the code I use to gather performance stats. They go into the database. If I go into server analysis, my server analysis database, server stats, there's my counter data for the operating system counters. And come on, mouse. SQL Server counters are here. And this is very useful but I like to have a report. And so I've created this. This is a reporting services report that requires a minimum of reporting services to SQL 2008 R2 because these are sparkline graphs. And what I did was I took the counters for a 24-hour period and put them in the sparkline graph. And I just picked percent processor used, batch request per second, buffer cache hit ratio, and page life expectancy. And I created the report in this way so that I could see the pattern on a day-to-day basis. I could see what's going on each day, and you notice there's this pattern of percent processor used over the course of a day. There's this pattern of batch request per second. You notice this little lull in the middle of the day. And then it jumps up, and then almost nothing until the wee hours of the morning where there's some activity. Again, buffer cache hit ratio, there's not a lot going on here. But finally, page life expectancy, I hope you see the same pattern that I do. And this is what coming up with a baseline really is all about. So this allows me, this report now, because we're at the very beginning of the year, the report order comes out a little screwy because reporting services considers this date a string. So the 1 somehow comes out before, the 12 comes out before the 1 for some reason. And because I am sorting in descending order, right? So 22, 21, 20, 19, and then we jump to today's information. So this is something that I have never, it's something that I figured out that it was just one of those things about reporting services that only bothers me in January. But I do report in this page, I report up to the last 35 days of data. And the reason I chose 35 was because it always makes sure that I've got a month end to look at. Because if I look at the month end in the first couple days of the month, I have the previous month end to look at as well, because the pattern will be different at month end than it will be on any other normal day. I wrote another report. Let's take a look in detail at this data from yesterday, the 22nd. I have another report. If I click on that, it takes me to the performance analysis report. The first report gives me spark lines. It's a generic, gives me a rough idea of what things look like. This is a detail report for the 22nd exclusively, and it gives me exact numbers. So you can see my buffer cache hit ratio is hovering on this 100 line, except where it drops down at, 3:30 in the morning. My processor percentage, though, here all through the whole day, it's showing me in the afternoon I'm hitting on 80% in a couple of cases. Just briefly, but it's something I might want to take a look at. Why am I jumping up? Why am I spiking up in there? My page life expectancy starts out just under 25,000. It drops down to about 8,000 through the night. It starts to jump up, and then right about here is where we run DBCC check DB, which is why it drops way down to the bottom. Then during the course of the day, we climb all the way back up to about 16,000, and then just after lunch, somebody does something every day that drops us back down to 10,000. And it stays there through the afternoon, and after everybody goes home, it starts climbing back up again. We can see how our system is busy. We have a little bit of a lull here and then some spikes. So it just gives me more detailed information on what's going on. I've got latency information here. I'm showing read latency of up to 3 seconds when I'm doing my backups, my nightly processing. Usually hovering around 1 second, but usually during the day everything's down where it should be. So there's probably just some some extra I/O stress during the middle of the night because of all of the overnight processing here. Block processes and processor queue length. I've got one case where my block processes jumps up here to what is that, about 17, and processor queue length is staying mostly fairly normal. We've got a few cases where it jumps up. And if I want to look at the detail under that, I've got the actual counters below that, and then I can page through and look for actual detailed data instead of looking at the graphs. But the graphs give me a pretty good heads up of what's going on. So, the other thing I want to look at is disk and database usage. I've got scripts for those. Let's look at disk usage. Again, and now this is an older version of the script. I haven't converted it to using the new comment-based help. This is a 1.0 version of the script. Instead of the try, catch, finally, I've got the old trap. This works well on a SQL 2005, SQL 2008, or 8R2 box. The other script works well on a SQL 2012 or later instance. I've hard-coded my destination server and database in there. So another change I made for the performance baseline code. But I'm using WMI to get the disk information. So GWMI is an alias for get WMI instance. My query is select asterisk from Win32 logical disk where drive type equals 3. Drive type equals 3 are my local drives. Even if I'm on a SAN, the SAN disk assigned to my server is still drive type equal 3, so this gives me back all of the disks that are not where I didn't do a mount network drive or something like that. So I get the disks or the computer name I've specified in my server name up here. So for that server, I get the disk information, and I pull out the volume name, device ID, size, and free space. And those values come back in bytes. So for each row I get back, I loop through that, I get the current date and time, I divide the size and free space by 1 GB. PowerShell allows you to specify 1 GB for 1 gigabyte, which is extremely useful. So this gives me a size value in gigabytes and a free space value in gigabytes, and then I insert into my disk usage table the server name, the performance date, and the values that I got back. And then I figure out a percentage. I also have a percentage free that I store in the database that I do in the calculation there. I use invoke SQL CMD to run that command, and it stores that data into the database. And if we go to my reports, I have a disk usage analysis report. Which reports information over time for each drive. Now see, you can see it's pretty static here. If we go to the H drive, backup drive, it's remaining at 350 gig, but you notice the free space jumping up and down here. So this just shows a normal pattern of usage. If I see my free space starting to drop down towards the bottom here, that's a pattern that I want to anticipate, and long before I reach that out of free space condition, I want to go to the boss and say, hey, I'm showing a pattern here that says I'm lower, my amount of free space is going down, and I want to take care of that. I need more disk. This drive is pretty static. This one, again, it's floating around. This is where the databases live, on the F drive. So nothing really earth-shattering here to keep track of. Log data is stored here, so transaction logs especially. But again, if I see this yellow line start to approach the bottom, that means I'm running out of free space, and I need to let the boss know that I'm running out of free space before I actually do. It's just a way of keeping track of what's going on, so you look good, and you don't, so things don't go wrong on your watch. Lastly, I'm going to look at, not that one, I'm going to look at database usage. Again, this is an older version of the script. My trap, my target database, and in this case, I'm going to use SMOs. Server Management Objects is a management API that Microsoft introduced with SQL Server 2005, and it provides, within a server object, a collection called databases. And in those, for each database object, it provides properties for each of those databases. So first I'm going to check to see if the database is accessible. If I attempt to run this against the database that's mirrored, and I'm looking at the mirrored pair, the mirrored database of the pair, the is accessible flag will be set to false. If I've got log shipping and it's I'm just updating the logs, and it's not, the database isn't available because I'm still restoring, is accessible is not going to be set to true. So as long as it's set to true, then I can get the current date and time, and I'm going to insert into my database usage table the server name, the date, the name of the database, the collation, compatibility level, whether or not auto shrink is turned on, the recovery model, and the size and available space of that database. Now, interestingly enough, for some reason in SMO, SQL Server reports size in megabytes and space available in kilobytes. So I solved that by dividing the space available by 1024, so I get consistency between my size and my space available on a per database basis. I store that again in a table. I can easily scroll through here and look for red flags, like if auto shrink were turned on at some point. I look and see what my recovery model is. But again, I have a report called Database Space Analysis. And I'm going to be sending Aaron the slide deck and the demo scripts after the session is over, so he'll make those available to you. And I am including the RDL for these reports. So you can use these reports if you choose. I do recommend you use a tool like SQL Sentry's Performance Analyzer or Redgate's SQL Monitor or SolarWinds Ignite, or there are any number of tools out there that you could use for these purposes. I often found myself in situations where I didn't have the budget, so I wrote these reports. So, database space analysis, you can see in this particular database, LROP01, that I had a slight growth of the database here. I had another growth of the database here. Obviously, that corresponded with an increase in the amount of space available for that database. If I was staying on top of things, I would not have seen growth like this, because really I should take this database offline in a time, or at least the application offline, at a time when nobody's using it, and manually increase the amount of space available. This looks to me like autogrowth. Autogrowth usually happens at a time that's the least convenient for that. I would avoid using autogrowth, and by looking at your database space usage over time, you should be able to anticipate when you're going to need to grow the databases manually. And that way you can control when that happens. So here's another database that stays fairly static. Here's one that, interestingly enough, is growing very slightly over time. And again, it's obviously doing auto growth. This is not a good thing. I know a little bit about the application behind this, so it's not as bad as it looks. This is actually something else that is actually being restored overnight from another sourced from another database. So here's one again that's staying fairly static. This one kind of is going down a little bit, but again, look at the space available numbers, and you can use these numbers and plot out a graph in Excel to tell your boss when you anticipate running out of space, where you can grow the size. You can increase the size of the database manually, or which is a far better way to do things than using autogrow. But I'm using PowerShell to gather the data for all of this. So let's go back. So I jumped ahead of my slides. I didn't remember that the disk space and database slides were after the performance counter demos, but that's okay. You've already seen the demos for this, tracking disk space and database space. I've already had this discussion. So let me know if you have any questions about this. But the queries to keep track of this are fairly straightforward. So just some references for you. If you are new to PowerShell, I strongly recommend using the book Learn PowerShell, Windows PowerShell 3 in a Month of Lunches by Don Jones and Jeffrey Hicks. It's a really, really excellent tool to get you up to speed on PowerShell. I've been using PowerShell since shortly after it came out in 2006, and I have this book, and I reference this book on a regular basis. There's always things that I don't remember, and it's a great source to bring you back up to speed on something that you may not have used for a while. In 2009, I wrote a white paper for Microsoft called Understanding and Using PowerShell Support in SQL 2008. So I recommend taking a look at that for some of the early discussions I had on using SMO and how you use SMO with PowerShell, just to give you some background. And over the last year, I've done a number of articles on SQL Server Pro about using PowerShell with SQL Server, and this is a link to that collection of articles. So please feel free to refer to any of those articles on any aspect of using SQL Server with PowerShell. And that is essentially the session. Aaron, are there any questions?
Yep, we've got a few here. Let me start with this one because there's more than one that are similar. Regarding memory in a virtual environment, it generally shows SQL using all available memory. Whether it is using it or not, how do you sort that out?
If you're in your guest operating system, if SQL is using all of the available memory, then what I would strongly recommend is you go in and set the max server memory to at least 2 gig below what the guest operating system is assigned. SQL Server will take all of the memory if you let it, and it shouldn't. And so you really do need to actively set that SQL Server property. It's called max server memory, and at minimum of 1 gig leave available to the operating system. But if you have enough, I would suggest that you might want to leave at least 2 for the operating system alone.
All right. Next one. We got several. Lots of people asked about the RDL file, so they were really happy to hear about that. One was, how do you find the data cache size? Talking about performance counters. That's when that came up.
The data cache size. I don't believe that is in the performance counters, but you can get that information from DMVs. So if you look for, there's a book on DMVs by Tim Ford and Lewis Davidson. If you go to Redgate website, and they've got a collection of books that they sell in hard copy, or you can download the PDF for free. And Tim Ford and Lewis Davidson's book on DMVs is available as one of those books, and it will discuss the DMVs that give you that information. But that I have not done in PowerShell.
All right, and several people asked variations of this one. Do you know if exists some special counters for VMs?
There are special counters for virtual machines. Those are outside the scope of what I've done for this presentation, and each VM vendor, essentially Hyper-V or VMware, has different names they have for the counters. But if you contact VMware or you contact Microsoft with respect to the counters for managing the memory at the VM host, they can give you that information.
All right. This is an interesting question. How is this approach better than, or is this approach better than SQL Server Data Collector?
That's a really hard question to answer. I tried using the built-in management, SQL Server management counter thing that they introduced in SQL 2008, and I found it to be extremely cumbersome, and the reports weren't particularly flexible for me.
I'd agree with you there.
So I felt it was cleaner and better to roll my own, and that's what I did here. It's,
might even some of the words around cumbersome, but yeah.
Yeah, and the other advantage of mine is it's as I hope you saw when I looked at the wrong window here. If I can scroll through this data and I can run any query I want to against these numbers, right? To look at patterns for a particular database over time or whatever. I don't have to rely on the report. I can go right into the data. The tool that Microsoft provided with SQL Server 2008 is not quite so friendly.
All right. Next question is, do you have any recommendation for cluster health for my SQL servers in a high availability group?
For cluster health, I don't have anything specific to those. One of the things I did was I wrote this code in such a way that hopefully it's fairly straightforward to understand what counters I'm polling, and then you'll have the code add the counters that you feel are appropriate for monitoring your environment. You might have to add a few columns to the tables and such. But as far as resources for what counters to watch, I would contact somebody like Alan Hurt or Jeff Hyten or Denny Cherry to get information on what counters are most appropriate for monitoring the cluster health. I just don't know those off the top of my head.
All right. And then the last one here is just multiple variations of, will the DDL for the SQL database that you're recording this to be available?
Yes, absolutely.
All right, great. And that was the last of the questions. And it looks like we're right at the hour anyway, so I think we'll call it a day here.
All righty, then I'm going to go ahead and stop recording.
Yep.
And thank you. I really appreciate everybody who came. Thank you so much.
Yep. And we're getting in a full screen streaming in of thank yous in the questions pane. So.
Thank you.